This is Pre-Calc section 6.8, part 2. We are working on partial fraction decomposition. Now, here's our steps. We are still checking to see if the numerator degree is greater than or equal to the denominator degree. So we look here and you go, oh yeah, x squared, but be careful. This is x squared times x really makes the denominator degree 3 because that's x cubed. So that means we do not start with long division. The denominator is already factored. That's nice. The factors of the denominator become the individual denominators. And then we have to find the right numerators. So you might think, if this is x squared times x plus 3, that my two denominators are just x squared, x plus 3. But you have to think about what x squared really is. X squared is really x times x. Those are each linear factors. So what the story is here is that this is really linear factors repeated. And when it's linear factors repeated, the denominators are just a little bit different. If you had added two fractions together and gotten this x squared times x plus 3, there's really two possibilities for having this common denominator of x squared times x plus 3. One possibility is what you're looking at right there. One of the denominators was x squared, and one of the denominators was x plus 3. But you also have this possibility. One of the denominators was x, one of the denominators was x squared, and one of the denominators was x plus 3. Since that is also a possibility, we cannot limit ourselves to just two denominators. We have to cover all the bases. And that's why it says, because there is a linear factor repeated, we must account for the linear factor and all of its powers. All of its powers up to this highest power. Since that's x squared, we had to go from x up to x squared. If that had been x cubed, I would have needed an x squared, and an x cubed, and then also the x plus 3. So anytime there's a linear factor repeated, that's what we have to do. So this is really what I have for my three fractions. I have one fraction with x, one fraction with x squared, one fraction with x plus 3. Now, we're doing the usual. We want to clear out the fractions. We need to multiply by the common denominator, which is x squared times x plus 3. I'm just going to write it on the one side because you know x squared times x plus 3 cancels with that. So over here on the left side, you have 2x squared plus 4x minus 5. Now to do this canceling over here, we can look at the fact that x is contained within x squared, and we end up with x times x plus 3 times that a that's already there. So that part becomes ax times x plus 3. Plus, for the b part, the x squared totally cancels out with that x squared. So just kind of pretend that's gone. And what we have then is b times x plus 3. And for the other part, I can move this over here. And you can see that that cancels with that x plus 3. And what you have is c times x squared. So that's what we have once we have cleared out the denominator. And this is the same thing that was on the other screen. It just looks a little bit neater. So this equation is valid for any value of x, but we want to be smart about what we choose. One of the values we're going to choose for x is 0, because if we let x equal 0, we're going to be able to cancel some stuff out. So if you put 0 in over here, that's gone, that's gone. All we have is negative 5 equals. If you put 0 right there, that's a times 0 times whatever, that goes away. And if you put 0 right here, that's 0 times c, and that goes away. So putting 0 here, 0 plus 3 is 3, times b is 3b. Divide both sides by 3, and we have a value for b right there of negative 5/3. The other value we'd like to choose that would be smart would be negative 3. Because if you put negative 3 in right here, negative 3 plus 3 is 0. 0 times this stuff goes away. Put negative 3 in here. Negative 3 plus 3 is 0 times b goes away. So it's just here and here. I really have to substitute in the negative 3. If I put negative 3 in here and here, negative 3 quantity squared is 9 times 2 is 18. 4 times negative 3 is negative 12. Minus 5 is going to give me a 1 right here. Now your choice. I did that in my head. You can type that in the calculator if you want to. Put negative 3 in here. Negative 3 quantity squared is 9c. And we end up with c is 1/9. So those were values of x that we chose that would be easy arithmetic. Now, we don't have any more of those values right up here that would create the zero situation. So I've got let x equal question mark. You get to choose. Now, I just choose 1 because that's very easy to do the arithmetic on. Not as easy as those, but it's not bad. So put 1 in here for x and that x. This will be 2 plus 4 minus 5 is going to give me 1. Put 1 in for this x and this x. A times 1 is just a. 1 plus 3 is 4. So this part right here is 4a. If we put 1 right here, 1 plus 3 is 4 times b is 4b. And if you put 1 right here, 1 squared is 1 times c is just c. And why did I pick 1? Because that arithmetic looked to me like it would be pretty easy. You pick whatever you want, but you'd like the arithmetic to be easy. Now what do we do with this? We substitute in these values that we already figured out. So 1 equals 4a, which we don't know, plus 4 times b, which was negative 5/3, plus c, which was 1/9. This is just a simple algebra equation to solve. Yes, there are fractions, so use your calculator if you want to. 4 times negative 5/3 is negative 20/3, plus 1/9 equals 1. What I did from here is I just added 20/3 over here. So now this is 1 plus 20/3, and that wipes that out. At the same time, I subtracted 1/9 from over here, which wipes that out, and now I have equals 4a. Using the calculator, you can do 1 plus 20/3 minus 1/9, and this is 68/9 equals 4a. Solve for a by dividing both sides by 4, and a works out to be 17/9. So there's our values for a, b, and c. A is 17/9, and be sure you put it in the right place. A was 17/9. B is negative 5/3, and C is 1/9. But we need to clean this up so that the 17 stays on the top, 9 goes to the bottom. Minus 5 over 3x squared plus 1 over 9 times the quantity x plus 3. And that is the partial fraction decomposition for that problem. We're going to get one that we have to deal with, long division. The numerator degree is greater than or equal to the denominator degree. That's a degree of 4, that's a degree of 2, so we must start with long division. The remainder will become the numerator of our new fraction. So long division, we start with x squared into x to the 4th, gives me x squared. Come back and multiply x squared times that whole deal is x to the 4th plus 3x cubed plus 2x squared. Notice I did already fill in the placeholders there when I rewrote this. Now draw the line, change all of those signs. That makes the x to the 4th cancel out. 0 minus 3 is negative 3x cubed minus 2x squared. Bring down your next term, which is 2x, and start dividing again. Negative 3x cubed divided by x squared is negative 3x. Come back and multiply negative 3x times all of that is negative 3x cubed minus 9x squared minus 6x. Draw the line. Change all of those signs. Cancels out. We get 7x squared plus 8x. Bring down your 7 and begin again. 7x squared divided by x squared is 7. Multiply that times all of that. 7x squared plus 21x plus 14. Draw the line, change all of those signs, cancels out, we have negative 13x minus 7. That is my remainder. I'm going to come back and use this at the very end, but it's the remainder I need to deal with right now, and it becomes this. My remainder goes on the top, and what's on the bottom is this denominator, but I'm going to go ahead and save a step and get it factored out right now. Here it is a little more neatly written, and we know to get rid of this rational equation, we need to multiply both sides by the least common denominator, which is x plus 2 times x plus 1. And here, that totally cancels with that, and all I have is negative 13x minus 7. Over on this side, when I multiply by this x plus 2 is going to cancel with that x plus 2. So that's gone. And all I have is a times x plus 1. And when I move this over here, and I'm canceling the x plus 1's, what's left is b times x plus 2. So that is my equation, and I'm ready to let x equal whatever I want to make the arithmetic easy. If I let x equal -1, I put -1 right in here, this becomes 0 and goes away, and I will end up with -1 plus 2 is 1, b, so that's just b. Put -1 in here, -13 times -1 is 13, minus 7 is 6. So very easily we end up with b equal to 6. Same steps over here, but now I have to decide what I want x to equal. If I let x equal -2, then putting -2 in here makes this become 0 and go away. So -13 times -2 is 26, minus 7 is 19. -2 plus 1 is -1, so this is -1a equals 19, which means a is -19. So even though we had to do the long division, the actual work with the partial fractions was not bad at all. Now remember, I said this was going to come back. This has got to be part of our answer. So it will then be plus a, which is -19 over x plus 2, plus plus 6 over x plus 1. And this -19 could be minus 19 rather than plus -19.